Alright, in this video we're going to talk about another quadrilateral, and that quadrilateral being our trapezoid. Our trapezoid is different from our parallelograms in that the trapezoid is a quadrilateral with exactly one pair of parallel sides. Remember, in our parallelogram it was both pairs of opposite sides were parallel. So if we look at our drawing of our trapezoid down here, we see that we indeed only have one pair of parallel sides. We call those sides the base, and so we have two of them. So we have base 1 here and base 2 here. The non-parallel sides will be called our legs, and the base angles of the trapezoid, as you see, we have B and C are base angles here, and down here we have angles A and D. Now we're going to look at a special type of trapezoid. We're going to look at the isosceles trapezoid. And I'm going to illustrate the isosceles trapezoid by using the knowledge that you already know about isosceles triangles. So I've drawn an isosceles triangle here, and we know it's isosceles because I have at least two sides congruent. Well, if we have at least two sides congruent, we know then that our base angles are congruent. So I'm going to draw those in, and we call these our legs. So there's vocabulary that we saw here in the trapezoid, and our base angles, and we know this is our base. So now we're going to take a look at our theorems that go along with our isosceles trapezoid. So here's my isosceles triangle. Again, let me go ahead and draw our base angles in there. Now think about if I were to draw a line parallel to my base. Now, does that kind of look like a trapezoid? As now we have two bases that are parallel to each other, and we have our two non-parallel sides congruent to each other, and again we call those our legs. So very similar to our isosceles triangle is our isosceles trapezoid. Let's take a look at our first theorem. It tells us that if a quadrilateral is an isosceles trapezoid, then each pair of its base angles will be congruent. So in this case, we would have angle A and angle D congruent to each other, and angle B and angle C congruent to each other. Our next theorem is almost the converse of our first one. If a trapezoid has one pair of congruent base angles, then we know that the trapezoid is isosceles. And our third theorem works with the diagonals of our trapezoid. If we have an isosceles trapezoid, the diagonals of the trapezoid are congruent. So your theorem states a trapezoid is isosceles if and only if its diagonals are congruent. So let's use these theorems and work a couple of problems. Alright, our first isosceles triangle. Well, how do I know it's isosceles? Well, the first thing I saw were the tick marks. And so I know that I have two sides congruent. And I've got side AB is parallel to side CD because of our markings. And so what we want to do is we want to find the measure of angle A. So angle A is down here. So I'll just put an X because that's where we eventually want to end up at. Well, we know that if we have two parallel lines and a transversal, we're going to use our consecutive angles theorem, and we know that they will be supplementary. So we're going to write out an equation. So we know that the measure of angle C plus the angle B will give us our 180. So if we substitute in C, because we know that that is 100, and we solve our equation, we find that the measure of angle B is 80. So we'll put that in there. And now we're going to use our theorem that tells us that if this is an isosceles trapezoid, we know that the base angles, being A and B, are congruent. So we're going to use that theorem. So we know that angle A and angle B are congruent, therefore we know that angle A equals 80. Let's take a look at the next one. All right, we have another isosceles trapezoid. We have our tick marks showing the legs congruent, and we have the bases that are parallel to each other. So we have a situation here. They give us that the length from J to N is 10.6 and the length from N to L is 14.8. So they've given us information about this diagonal, and they want us actually to find the length of diagonal K to M. Well, we're going to use what we know, our theorem. We know that our theorem, if we have an isosceles trapezoid, we know that the diagonals will be congruent to each other. So we're going to say that, okay, given that theorem, we know that the segment KM is congruent to segment JL. Well, then we know that they are also congruent to each other. So really, we're just going to use our segment addition. We're going to add the two segments JN and NL, and together they equal this diagonal. And if we add those together, we get that the 10.6 plus the 14.8 gives us 25.4. And since we know that these diagonals are congruent to each other, we can then conclude that Km is the sum of 25.4. Alright, so that's a quick look at trapezoids and isosceles trapezoids. I have put a worksheet in Edmodo for you to work. There's 8 problems on it, and if you would like to go back and review this before you work on those, go right ahead and do that, and then work those 7 problems that will be due next class.